those sparkling dots are up there?
Oh, I don't wonder. I know.
Oh, what are they?
They're fireflies. Fireflies that got stuck up in that big bluish black thing.
Oh, gee. I always thought they were balls of gas burning billions of miles away.
But with you, everything's gas.
Okay, kids. So that is one smart warthog, huh? Today we're going to be studying stars. They are not fireflies stuck in that big bluish black thing. Ask your moms to come and sit with you, or your dads, to watch science with you so you guys can discuss it. Because science, a lot of times, leads to really good discussions about who made the heavens, right? The heavens declare the glory of God. I would argue, even though that's what Scripture says, that the heavens also declare a lot of other attributes about God. His mercy, right? There's a lot that can be taught about theology when we study science, right? And that's why I so hope that some of you will go into science fields, because we need strong Christians to work in science because it glorifies God, right? Many people throughout history have been led astray by people claiming science essentially as a god. Today we're going to talk about stars. Stars themselves have been worshipped as gods. We've studied the Romans, the Greeks, the Egyptians have stars that were named after gods. They were many cultures. India, China had gods made out of heavenly bodies, right? But we worship the great God who made all of them, right? We also know, even to the present day, people who look to the stars for guidance, rather than looking at the one God who provides for all our needs, right? So let's study stars, okay? What is our sun made out of? Does anyone remember our memory work? Our sun is made mostly of hydrogen and helium, which are two elements. And my little kids, we've talked a lot about lots of big concepts, but an element, there are certain things that you can't break down any further. And there's a table of elements of all the elements we've discovered in nature. Helium and hydrogen are among the lighter ones, and that's what most stars are made out of. But they also have carbon or oxygen. Some have probably iron, a few other things. And what's so cool that I've talked with my little ones about is energy cannot be created nor destroyed. God spoke it into existence, and it just changes form. And so every star has a life cycle where they're created, and then they burn those gases for a period, a constant process of nuclear reactions within the star. Our sun and other stars behave the same way. They each have the same parts. Let me just look really quickly. They have a core, a radiative zone, a convective zone. For us in the photosphere, they have prominence, which is kind of like the glow around them, and a corona. There are also parts where they explode, like, what's the word for it? I can't think of it right now. And then spots, sunspots, where there are spots that appear darker. All stars have that. That's what our sun has. But what's so cool is as they age, they change. Do we change as we age? Don't look at my wrinkles, you guys. Yes, of course we change as we age. And so do the stars. And eventually what happens is stars die. They shrink and either become a white dwarf, or sometimes they explode in this very cool thing called a supernova. 37 times in the past 1,000 years have people been able to witness supernovas with their bare eyes. But you know what you have to do to see a supernova? You have to be watching the stars. You have to go outside and look at them. So people who watch very carefully and see how stars change over time have been able to see when stars actually explode. Isn't that amazing? And what happens is then they collapse and become so dense, and the gravity becomes so great, either as a white dwarf or after a supernova, that they pull other things in. But they can also, if they don't get to the point of becoming a black hole, they also, when they explode, send stuff out. And that stuff that they explode becomes the basis of new stars. It's this wonderful process of recycling material. And God's in control of all of it. Why do we study it? Why do we care? You guys know better than to ask that. Why do we care? Because God made it. It glorifies Him. And also, a lot of things in science, we don't know why we're studying them now. But down the road, the knowledge that we attain now helps us in the future, right? So let's get into it. There are types of stars. So our sun is a relatively small star. There are smaller and there are bigger. Generally, stars are sun size or slightly smaller. As they age, will gradually swell as they're letting off more of the gas. They become what's called a red giant. Okay. What's interesting is I always think of red as very hot. With stars, they have different colors, and the color of a star tells us how hot that star burns. How hot, like the process of nuclear reactions within the star, the temperature. Remember, energy can take the form of heat and light. That temperature, the blue stars are the hottest. Let me double check one of my books right here. I have so many cool books. I love these books. I hope you guys have some cool books at home, or go on the library website to find some. There are tons of very cool books. Right here, it shows you the temperatures. Blue is the hottest, and red is actually the coolest type of star. So as stars the size of our sun swell, they become red, and they cool. And then eventually, as all that gas burns off, they shrink down and become white dwarfs. They're very heavy. Imagine a golf ball that has the weight of a truck, except star size. So very, very dense. Bigger stars, bigger than our sun, actually grow into red supergiants, and then eventually cause a huge supernova. And then that supernova either spreads dust and other debris across space that can form new stars, and just leaves a little star spinning in the middle of where that explosion was. Or it can form a black hole. So amazing. So our galaxy, as I mentioned, it's about 389 billion miles across the Milky Way galaxy. We're going to study galaxies next week. We have at least 200 billion stars. At least 500 of them we've already discovered planets around. The two closest stars, this is our memory work for this week. I'm going to grab my sheet because I have a hard time memorizing it. Do you? No way. You guys are so good at this. The nearest star is Proxima Centauri, 4.2 light years away. This is part of the constellation the Centaur. Let me see. There we go. In the southern hemisphere. Okay. It's down here. And what's very cool there is there are multiple stars right near each other. These two are Centauri A and Centauri B. And they actually rotate around each other. It takes about 80 years that their gravitational pull pulls on each other so that they orbit around in a circle. There's another star right near them called Proxima Centauri, and that is our nearest star. It's 4.2 light years away. Okay? These are about 4.3 light years away. And what's amazing with them is one of them, we've discovered a planet about the same size as Earth, right around it. So kind of cool to think of someone being able to discover a planet while staring at a very bright star very far away. So the nearest star is Proxima Centauri, 4.2 light years away. The brightest star is Sirius. The biggest star is Canis Majoris. So Canis Major. I wrote this to the Star Wars theme because I love to sing. Don't make fun of my singing. The nearest star is Proxima Centauri, 4.2 light years away. The brightest star is Sirius. The biggest star is Canis Majoris. Do you think you got it? I hope so. You don't have to sing it if it doesn't help you, but these are good things to memorize. So we study stars, but it's hard. It is hard to study stars. If you've gone out, for one thing, you have to go out late at night. The other thing is, let's say we have our Earth. I'm going to pretend this cup is the Earth. And this cup is our sun. Right now, with our Earth, can we see stars that are on the other side of our sun? No, there's a great big star in the way with tons of light. This is during the daytime. When we're facing the sun, it is daytime. So right now we can study all the stars that are on the other side of the Earth at night. Okay, so what's amazing is if you've ever looked at a paper map, there's north, south, east, west. What's interesting is when you study stars, we study it in a three-dimensional realm, okay? It's called the celestial sphere, and we've actually mapped out a ball of stars that we're able to see from Earth. Okay, so at certain times of year, we can see the ones that are over here. As we rotate over here to the other side of the sun, we can suddenly study stars over here, and over here, right? We go to the other side, and we can study stars that are on the other side of the Earth, the sun of the Earth. And then over here, we can study stars over here. So each time of year, we can see different stars at different angles and see them better or worse, okay? It's very hard to study stars. They're very far away. They change. They're pretty constant. But over time, you have to be really attentive to catch all the changes. You have to go out every night to be able to tell if a star is a variable star. There are pulsing stars. There are, let me see, what are other terms for stars? There are pulsing stars. There are, let me see, pulsating stars that shrink and swell. They give off different amounts of light, but you have to go out every night to be able to detect that. There are eclipsing variables, kind of like the Proxima or the Centauri A and B. As they orbit around each other, one can get in front of the other, right? Which changes the amount of light that we see from that spot in space. There are also flaring stars or cataclysmic variables. This is when two binary stars like Centauri A and B are very close together, so much that their gravity starts sucking some of the material towards each other. Isn't that kind of neat? But you have to get out and study them. The other thing is we have this thing around the Earth. Can any of you think of what surrounds the Earth? I know a lot of you want to say magnetosphere. That does affect things. But more importantly, our atmosphere. The very thing that protects us and gives us just the right amount of gases for us to be able to breathe and support life on our planet also messes with light from out of space. Okay, it protects us from UV rays, which is great from the sun. But when you're studying stars, it sure is hard when all the light from these stars very far away comes through our atmosphere and it gets distorted. So you know what scientists did? In April of 1990, when I was a little girl younger than most of you, scientists made a fantastic new telescope called the Hubble telescope. It is still one of the most important things we use to study space. Can I show you a picture of it? Let me see if I can find it. I have so many books. Forgive me for having so many books. I just find this great fun to learn about because it's something that I didn't study when I was a kid. Have any of you told your parents what I do for a living? I know I'm your science teacher, but what do I teach most of the time? Do you know? I'm an economics teacher. I study money and decisions and how countries grow. So this science stuff is really fun for me because I'm learning with you. This is the Hubble Space Telescope. It is 47 feet long and 15 feet across. It's a reflecting telescope. So what it does is it takes in light from a source and reflects it off of mirrors into an eye. And then it has 5 different instruments that use that light to interpret it and make information about the stars and what they're made of, what their history is, how they're changing, that kind of thing. It's amazing. What happened is they were able to shoot the Hubble Space Telescope take it into space, outside our atmosphere, without any distortions. And now they can study stuff that is 14 billion light years away. That's tremendous. It opened up a whole new world for scientists to study space. There was a problem with its mirror, and we used the Space Shuttle Endeavour to go and fix that. But for the past 30 years, we've been getting phenomenal pictures. There is a picture I'm going to share with you guys next week. This one, it was taken by the Hubble Space Telescope. But I have some very cool pictures that I'll share with you next week of various galaxies. So, you guys, I hope you get a chance to go out and study some stars this week. Some of you in my younger class have already made these, but I'm going to send your parents a link in case you don't already have them. This is called a star map. What you do is you line up the month of the year. So let's say it is March 31st now. So here's March 31st, and I go out at 7 p.m., right when it gets dark. These are the stars that are going to be in my sky. If I hold this up and point the side that says northern horizon towards the north, I can use my compass to find that, or my cell phone. I can tell which constellations I'm looking at. You can also use the Skyview app on your phone. There's a free version that's fantastic. Let me see, the most common constellations that are easiest to find. Ursa Major. Let me find a picture. I don't know who drew this. This is supposed to be a bear. But have you ever seen a bear with a tail? Go figure. The Big Bear, for those of you studying Latin. Most of the constellations have names that are from Latin. So it's kind of neat if you study what they mean. Ursa Major, they group stars to help you remember where they are in the sky and what's near each other. They used this historically for navigation. And you can still use the constellations to help you navigate. If you know where stuff is in the sky, it can help you figure out which way you're heading when you're in the woods, when you're sailing. Henry the Navigator, Prince Henry of Portugal, trained sailors in studying the stars in the 1500s, right? I believe, maybe 1400s, so that they would know where they were when they were in the middle of the ocean or sailing around Africa for the first time, right? So here is the Big Bear. Do you see the Big Dipper right there? That is one of the easiest constellations to find in the sky. And similarly, there's the Little Dipper, which is part of the Little Bear. I'm going to find my picture of the Little Bear because that's an important one to know how to recognize, because there's an important star within the Little Bear called... my Little Bear is missing. I can't find it right now. I have too many constellations in front of me. But the Little Bear... There we go. Found it. Little Bear, and you can find over here in Ursa Minor the Little Dipper. A dipper is a thing that you would use, like a ladle, okay, that you would get milk or something out of a bucket. The neat thing is if you can find this, at the top is Polaris, the North Star. That's how you can tell where is north. Also, another easy constellation to find near it is a very long constellation called Draco, the dragon. Isn't that neat? So you now know Ursa Major, Ursa Minor, and Draco the dragon. The other ones that I find easiest to find are Cassiopeia. It's a W. Certain times of year it's easier, but you should still be able to see it this time of year. I will see around 7 p.m. It will be right just west of north, okay? There's Cassiopeia. It forms a little W, okay? This is how the ancients viewed it. There's your W, and they imagined it being a woman, right? Some other ones that are easy to find, certain times of year, there's Gemini, the twins. They line up nicely. There's 3 dots and 3 dots that are the most obvious part of Gemini. Okay. And then also easy to find is Orion. Let me see if I can find my Orion sheet. Orion the Hunter. Let me see. Here's one of Canis Major, right? Which these are the stars that make up Canis Major. In our night sky, they're going to be on the southern horizon, right there. Do you see that? And here is Orion, the Hunter. So it's just off of Orion. Do you see that? So Canis Major, and then Orion the Hunter. That is a fascinating one to study, especially if you can take out your telescope, you guys. So Mr. Campbell and I, when we first got married, he showed me with his telescope. It was the first time I'd ever seen a nebula. A nebula is a place, it's where stars are born. Not in Hollywood, you guys. That's what people would say who are celebrities. But stars are born, true stars are born in nebula. So Orion, the Hunter, the nebula is, Orion's the easiest to find in December through February, but you can still find them. Okay, if you look on his right hip, just below there, with a telescope especially, or binoculars, you can easily see it with binoculars. In the middle of where his sword would hang is one of the easiest nebula to see. That's where stars are born. Also, I think on the left side of his belt is, no, it's also on his right side. Right below his belt, on the right side, is the Horsehead Nebula. It actually looks like a horse head. It's very cool. Maybe look it up online. Up on his left shoulder is another famous star called Betelgeuse. Not like the movie. It's a red supergiant. It's 800 times the size of our sun. And it's on Orion's left shoulder. So maybe try to take out a telescope or look those up online, or try even with binoculars. Try to find it just with your eyes, you guys. Go ahead and enjoy the sky before it starts getting too light at night. You can easily see stars if you go out somewhere dark at 7 o'clock at night before the sun sets, maybe 8. Certainly, if you can stay up till 9, you can see stars. Or if you can get up super early around 5. One thing I love this project that I made with Holly. This just has a little light on the bottom of it inside that you can turn on, and it shines all of the common constellations in the northern hemisphere and then in the southern hemisphere. We don't see the same stars in the northern hemisphere as they do in the southern hemisphere. I had planned for you guys to make a project with some cups and our little finger flashlights. I'm going to send to your parents a printout of various constellations and what you can do with your constellations. Let me see where I just set that down. Is you can then tape the constellation on a paper cup, or just on a sheet of paper, and on a toilet paper tube is another idea. And this is Cassiopeia. You can do it on that end, or you can do it on the side of your cup. Or if you want, you can even do something like make a little candle holder out of clay. If you have air dry clay or the kind that you make in your oven, you can make a little pot type thing and use a pin to prick your little constellation of your choosing into it. And then if you make a little pot out of clay, or even if you take a glass and paint the sides of it and then just mark out spots in the paint for the stars, you can put a tea light in there and then shine your constellations. Or with this kind of thing, you can tape your finger light on the inside and go in a dark room and shine just where the stars are. Isn't that kind of neat? One tricky thing I should warn you guys when you're studying the constellations is that even though we group the stars together, many of them are actually nowhere near each other in the celestial sphere. Some of them might be billions of light years further than others, okay? So like Cassiopeia looks like a W to us, but it's not flat. One of the stars may be close to us while another one is really far away. And depending on its size and brightness, they appear as one constellation, the W, even though they're very far apart in space. So you guys now have everything you need for this week for science. I encourage you to get outside and look at the stars. Print out a copy of the star map. What you're going to do is cut it out. You cut out the circle, and then you're going to cut out this sheet like this, fold it, and then stick the circle inside of it. Take a pair of binoculars or a telescope if you have one, and see if you can find the nebula and the sword of Orion's belt, or the Horsehead Nebula, which is really hard to see unless you have an actual really good telescope. But certainly this nebula that's right underneath Orion's belt is easy to find with a pair of binoculars. It looks fairly colorful. And then also print out the constellation card so you can try to make some cool patterns. And make sure you're reviewing your science memory work. I know it's easy to skip when you're focused on spelling and Latin and grammar and writing and math and history and all your other memory work, Bible and catechism. But remember, we studied Earth's moon. We talked about what causes ocean tides. We talked about eclipses, both lunar eclipse and solar eclipse. We talked about what makes a planet a planet. It has to have its own gravity, orbit around a sun, be shaped like a ball, and have cleared its neighborhood. And then we learned the names of the planets, the terrestrial planets, Mercury, Venus, Earth, Mars, and the Jovian or gas planets, Jupiter, Saturn, Uranus, and Neptune. And this week we learned about stars. The nearest star is Proxima Centauri, 4.2 light years away. The brightest star, seriously, it is seriously bright. The brightest star is Sirius. And the biggest star is VY Canis Majoris. Good job with your memory work, and I look forward to talking to you soon. And Mrs. Cheney says hello. Bye, you guys.